NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1 just turned back and uncovered something terrifying, billions of miles away. Imagine this, a small, decades-old spacecraft, now the farthest man-made object in space, still sending us urgent, shocking news from the depths of the cosmos. Despite its ancient tech, it has discovered something so alarming that it's got the whole world buzzing with worry. What has Voyager 1 found out there in the dark? Join us as we investigate this cosmic mystery and explore the consequences of its shocking discovery. Voyager's uncharted journey beyond the stars. Voyager 1 is still out there, traveling through space, facing challenges we can't even imagine. It's a reminder of how much we can achieve with curiosity and determination. Even after all these years, it's still teaching us new things about the universe. Just when you think it can't get more interesting, Voyager 1 sends back data that makes scientists rethink what they know about space. This mission, which started decades ago, is still full of surprises. It's like a treasure hunt that never ends, always giving us more to wonder about. And the most amazing part? This little spacecraft, so far from home, continues to work tirelessly, showing us that sometimes the oldest tools can still give us the most valuable insights. The journey of Voyager 1 is a story of perseverance, discovery, and the endless possibilities of space exploration. The idea of the last frontier makes us think about what lies beyond our planet and what it means for people on Earth. Let's explore the unknown and see what the universe holds. In 1965, something amazing happened. It was the start of a new time in space exploration. At NASA's Jet Propulsion Laboratory, a talented person named Gary Flandreau had an exciting job: to plan the perfect path for a space probe to visit the giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune. Using just a pencil, an engineer's favorite tool back then, Flandreau made a remarkable discovery. He found that in the late 1970s and early 1980s, these four giant planets would line up in a rare alignment, looking like a string of pearls with Earth at one end. This unique event would allow a space probe to take a grand tour of these distant worlds, something that wouldn't happen often. This discovery opened up new possibilities for space travel, leading to the Voyager missions. These missions aim to bring us closer to these far-off, gas-filled giants than ever before. They promise not only to teach us more about our own solar system, but also to amaze people around the world with pictures and information from far beyond our planet. Flandreau's work showed the power of human curiosity and our endless quest for knowledge. The alignment of the planets was more than just a lucky break. It was a chance to make new discoveries and expand our understanding. Through these explorations, we weren't just reaching out into space. We were also finding new ways to see our own world from a broader perspective, inspiring generations to look up at the stars and dream about what lies beyond Earth. But this wasn't the only amazing part. The journey of the Voyager missions also revealed incredible details about the planets they visited, showing us just how diverse and fascinating our solar system truly is. Sarah's life in the city takes an unexpected turn as she seeks balance amid the hustle and bustle, finding stillness in the city that never sleeps. Living in a big city can be exciting. There are always things to do, places to see, and people to meet. But sometimes all this hustle and bustle can be a bit overwhelming. Take Sarah, for example. She moved to the city with dreams of adventure and new experiences. At first, everything was amazing. She loved the tall buildings, the busy streets, and the endless opportunities. But soon, Sarah started to feel tired. The noise, the crowds, and the constant rush began to wear her out. She missed the peace and quiet of her small hometown. One day, after a particularly long day at work, Sarah realized something. She hadn't taken a moment for herself in weeks. She was always on the go, trying to keep up with the fast pace of city life. Sarah also noticed that she had stopped enjoying the little things that used to make her happy. She missed the simple joy of a quiet morning or a leisurely walk in the park. Sarah decided to make a change. She started by setting aside some time each day for herself. She found a small park near her apartment and made it a habit to visit every morning. Just a few minutes of peace made a huge difference. And as she began to slow down, she rediscovered her love for the city. She still enjoyed the excitement and opportunities, but now she balanced them with moments of calm and quiet. Sarah's story shows that even in the busiest places, it's important to take a step back and find your own peace. When no one thought it possible, these amazing space travelers proved everyone wrong. They went far beyond their planned 4-year mission. These space explorers had some surprises early in their long journey through space. They showed us amazing close-up pictures of the moons orbiting Jupiter and Saturn. These moons were much more active and lively than we ever thought. Their discoveries included boiling volcanoes and moving ice fields. The Voyager spacecraft broke all expectations and changed how we understand these distant places. Voyager 2 took an incredible path through the stars. It was the first to reach Uranus in 1986 and then flew by Neptune just 3 years later. No other spacecraft has done this. It amazed scientists with new discoveries in unexplored space, more than 14 billion miles away from Earth. These small probes, each the size of an old Volkswagen Beetle, have gone beyond all expectations and keep pushing the limits of our knowledge. The incredible path of the Voyagers began with a move around Venus to gain speed. This had never been tried before by any other spacecraft going to Mercury, making them true pioneers. But this was not easy. It required very precise timing, with only a few minutes of error allowed, and several tries were needed to get it right. The first part of their journey to Jupiter took them 10 times farther from Earth than Mercury, through very dangerous areas of space. But this wasn't the hardest part. When they reached Jupiter, they had to navigate through intense radiation belts that could damage the spacecraft. The Voyagers sent back stunning images and data, showing us new things about Jupiter's atmosphere and its many moons. This information was more than scientists had hoped for and helped us understand the giant planet better. After Jupiter, the next stop was Saturn. The Voyagers gave us our first close look at Saturn's rings and its mysterious moons. We learned that one moon, Titan, has a thick atmosphere, unlike any other moon we had seen. The data from Saturn helped scientists learn more about how planets and moons form and behave. The journey through space uncovers surprising wonders as the Voyagers venture into the unknown. Voyager's endless journey. Next came Uranus and Neptune. These were the last planets the Voyagers visited. The spacecraft sent back amazing pictures and data, showing new details about these distant planets and their moons. We discovered that Uranus has a tilted axis, causing extreme seasons, and that Neptune has the fastest winds in the solar system. But that wasn't the end of their mission. After passing Neptune, the Voyagers continued into deep space. They are still sending back data, helping us learn about the outer edges of our solar system and beyond. The Voyagers have shown us that there is so much more to discover in space, and their journey is far from over. The asteroid belt used to be a big topic of discussion and guesswork, especially before the 1970s. Pioneer 10 and 11 bravely navigated through what was believed to be a crowded cluster of asteroids without any damage. This paved the way for the Voyager missions, which had their own challenges. The Voyager spacecrafts had only 69 kilobytes of memory, a tiny amount compared to today's smartphones. Their computers had to manage all the complex tasks of their space journey on their own. They collected important data and stored it on 8-track tape recorders before sending it back to Earth using a weak 23-watt transmitter, which is no stronger than the light in your fridge. To communicate, the Voyagers used 12-foot wide dish antennas and sent messages via radio waves at light speed. As the Voyagers traveled further from Earth, moving 3 or 4 light seconds each day, staying in touch became harder. It took more than 18 hours for signals from Voyager 2 to reach Earth. Plus, the increasing noise from earthly sources like radios, TVs, and mobile phones made it even tougher to hear the faint signals from the spacecraft. But this wasn't the worst part. Despite these technical and distance-related problems, the Voyager missions have continually delivered surprising discoveries from beyond our solar system. They have greatly increased our knowledge and changed how we see the vast universe. The Voyagers have kept the curiosity of astronomers and the public alive, offering new insights and changing our view of the unknown. Far out in the vast space beyond our solar system lies the Oort cloud. This area is full of objects that look like comets, all held together by the sun's gravity. The Oort cloud stretches almost halfway to the nearest star, yet it's a place we've barely explored. Our space probes are slowly getting closer, navigating this distant area. Closer to us, just beyond where the solar wind stops, is a more reachable zone called the heliopause. This boundary marks the end of our solar system and the start of interstellar space. Scientists once thought the heliopause was about 50 astronomical units away. This estimate led to an increase in the mission's budget. But as our spacecraft crossed this boundary, they didn't find the expected signs of interstellar space. They were looking for a sudden spike in galactic cosmic rays, which are high-energy particles from exploding stars, moving almost as fast as light. This barrier protects our inner solar system from outside dangers. The Voyager team watched closely for any changes in the main magnetic fields as the spacecraft went deeper into space. While it confirmed an increase in plasma density as expected, the direction of the magnetic fields didn't change, which was a big surprise. Scientists thought that moving from a region dominated by the sun's magnetic field to one influenced by other stars would naturally change the magnetic field's direction. This unexpected finding has led to more investigation and interest in what lies beyond our solar system. At the solar system's edge, the Voyagers reveal new mysteries with every mile they travel, charting unknown realms of space. Voyager 2 began an amazing journey to the edge of space. It reached the heliopause, the outer boundary of our solar system, about 120 astronomical units away from Earth. This was the same distance its twin spacecraft had reached 6 years earlier. But scientists were puzzled because Voyager 2 didn't notice any changes in the magnetic field, which was different from what their models had predicted. This added a new level of complexity to their understanding. The models had suggested that the heliosphere, affected by the sun's 11-year activity cycle, would expand and contract like solar winds. But the observations didn't match these expectations. The data showed no such changes, even though the solar winds were particularly strong when Voyager 2 made its entry. This hinted that the heliopause might have been farther than 120 astronomical units. As the Voyager probes moved closer to the boundary between our solar system and the rest of the galaxy, they gathered data showing tiny changes near the heliopause because of the heliosphere's dynamics. Even with these small changes, the larger magnetic field stayed mostly the same. This made scientists ask more questions about how these forces behave at the edge of interstellar space. The probes kept sending back data that challenged existing theories, suggesting that our solar system's outer edges are more complex and dynamic than we thought. We'll move past these tough parts of space and might find the real interstellar magnetic field, unless our current ideas are completely wrong. Some experts think that we might still be traveling inside the heliosphere, while others believe that the increase in cosmic rays and plasma density seen by the spacecraft supports another idea. Figuring out the heliosphere is like a goldfish trying to see its own bowl. We need a probe outside the heliosphere to make things clear for us. Even though old technologies like answering machines, VCRs, and pennies have become obsolete, the Voyager missions keep surprising us with their long-lasting and strong technology. But this isn't the most surprising part. The Voyager missions, launched over 4 decades ago, are still sending back valuable information, proving their worth again and again. The spacecraft have gone farther than anything else humans have made, and they're still working, even though they're far away from home. It's amazing to think that these old machines are still teaching us new things about space. However, the journey isn't without its problems. It's incredible how much we've discovered from these tiny travelers. But the most fascinating part is that they might still have more to show us before their journey ends. These spacecraft use technology that was created 50 years ago, running on very basic software. The engineers back then didn't use complicated programming. Right now, Voyager 2 has 5 working tools, while Voyager 1 has 4. They both get their power from a device that turns the heat from decaying plutonium into electricity. However, NASA has had to be very careful with how they use this power because it drops by about 4 watts every year. Just 3 years ago, the mission's engineers had to turn off the heater for the cosmic ray detector, which is a crucial tool for knowing when the spacecraft crosses the edge of our solar system, called the heliopause. Surprisingly, the detector kept working even in temperatures way below what it was designed for. But that wasn't the most surprising part. The device's continued operation, despite the extreme conditions, was truly remarkable. Moving forward, both the magnetometer and the plasma science tool are expected to keep giving us valuable information. The spacecraft continue their journey, facing new challenges and pushing the limits of exploration, powering Voyager's last journey. The engineers are doing everything they can to keep the Voyagers running as long as possible, even with the power slowly dwindling each year. But this isn't the only challenge they face. Every year, they have to make tough decisions on which tools to keep running and which ones to turn off. Yet it's not just about managing power. These spacecraft are far away, making communication a real challenge. But despite the distance, the data they send back continues to amaze scientists. And while communication is a big hurdle, the cold of space is another challenge. These spacecraft are operating in conditions far colder than they were built for, yet they keep going. This resilience makes the Voyagers an incredible feat of engineering. But this wasn't the worst part. The mission's future is also uncertain due to the constant drop in power. The engineers must continually find innovative ways to stretch the remaining energy as much as possible. If everything goes well, scientists think these missions can last until 2030. But the key factor that will decide their fate is power. Despite the challenges, the Voyagers continue their journey through space and time. In an amazing 16,700 years, Voyager 1 will drift close to Proxima Centauri, the closest star to us. Then, 3,600 years later, Voyager 2 will reach the same point. But this isn't the most surprising part. They will keep orbiting the galaxy for thousands of years, long after our sun fades and the heliosphere is gone. These probes will stay as quiet witnesses to the vast universe, traveling far beyond any human time. The space probes are still out there, unharmed, unlike our small blue planet. One day they might send back a last message, but it won't be through regular ways like radio. If they do, there won't be any humans left to hear it. The tale of these space missions shows how deep our curiosity runs and how much we want to explore, pushing the limits of both time and space. We're invited to think about these space journeys and talk about their long-lasting effects. These space probes represent our never-ending quest to understand the universe. They travel farther than we can imagine, going beyond our solar system and into the vast unknown. Each piece of data they send back helps us learn more about the cosmos and our place in it. Imagine the excitement when these probes were first launched. Scientists and engineers worked tirelessly, hoping their creations would survive the harsh environment of space. And they did. These probes have lasted far longer than anyone expected, continuing to send valuable information back to Earth. But here's the thing. As these probes journey through space, they remind us of our own planet's fragility. Our Earth faces many challenges, from climate change to pollution. These space missions make us reflect on how we treat our own world. Despite all this, the probes keep moving forward. They symbolize hope and perseverance, showing that even in the face of adversity, we can achieve great things. They inspire future generations to dream big and strive for the stars. Will future space missions reveal life beyond Earth, reshaping our understanding of the universe? Comment, like, and subscribe for more.